friends, welcome to GeeksforGeeks YouTube channel. In this video, we'll solve one more tricky C question. Hope you're excited, so let's get started. So I have taken a simple if-else which consists of a condition involving logical OR operator. My intention here is to reveal the difference between logical OR and bitwise OR. So we have x equal to 10 and y equal to 15. First of all, what an OR operator will do, whether it is bitwise OR or logical OR. If any of the condition is true, then the output will also be, otherwise output will be false. That means OR will return false only if both the conditions are false. If any of them is true, then the final output will be true. That is what OR will do. And we have bitwise OR and logical OR. Similarly, bitwise and logical AND, that we will see in the next session. And coming to this statement, plus x greater than 10. What will happen if plus x greater than 10 is evaluated? Plus of x, that means it is a pre-increment operator on x. That's why plus of x will be 11, and also x value will be changed to 11 because it is a pre-operator. Greater than 10. This condition returns true. Yes or no? Yes. And plus of y greater than 15. That means y becomes 16. 16 greater than 5 is true. That's why second one also would be true. Final output will also be true, because this will return true and this will return true. And this statement, this evaluation of this condition makes y to 16. Okay, y becomes 16 if second one is evaluated, and x becomes 11. But if you see, this is a logical operator. One thing I will ask you, the first expression, if you evaluate the first condition, the output is true. We know that if one condition is true, then the final output would be true. Final output of the OR would be at this point of time after evaluating this. So this expression is resulting true, and we have OR operator. Irrespective of whether this condition returns true or false, the output would be true only. Whether this condition is true or false, no matter, the final output would be true only. So in that scenario, what is the need to evaluate the second expression? Whether you evaluate or you don't evaluate, the final output would be true. So that's why in the case of logical operators, the second expression will not be evaluated. That means the second expression would be evaluated only if needed. So if the first suppose if the first expression is false, then we don't know. Second expression might be true or false. So there is a necessity to evaluate the second expression, because still we cannot say the final output of this logical OR expression is true or false. So in that scenario, this will be evaluated. So when logical with respect to logical OR, second expression will be evaluated only if the first expression is false. That is, we are unable to decide. If the first expression is true in the case of logical OR, then second expression need not be evaluated. We can come to a conclusion that the overall expression will result in. But if you take a bitwise OR, this will not happen. Whether it is first expression is true or false, entire expression will be evaluated. You can also take bitwise OR here. You will get the same output. But the difference is that expressions evaluation will change based on the requirement. Expressions will be evaluated. That is what the difference between logical OR and bitwise OR. So for this reason, this logical operator is also called as lazy evaluation operators or short circuit operators. Why lazy evaluation? It will evaluate only if required. Unnecessarily it will not evaluate this expression, second expression. So the condition is true. The overall expression is returning true. So what control goes to x plus plus. I mean control goes to control goes inside the if block. That is x plus plus will be evaluated. So x plus plus will make x to 12. Okay, and else will not be executed. So what is the final value of x? X will be 12 and y will be 15 only, because this will not be evaluated. That is what you should know. I'll just x equal to 12, y equal to 15 is the output. For suppose if I take something like this, then what will happen? X plus x, that means 11 greater than 10. 11 greater than 10 is false. That's why 11 greater than 10 is false. Can we decide the final output is true or false in the case of OR? No, we cannot. So second expression might be true or false. Based on that, we can come to a conclusion. So for this reason, in this case, second expression is evaluated. Why? Because first is false. So plus plus y becomes 16 here. So x becomes 11 and y becomes 16 because this has been evaluated, and the final output would be true only here also. False and true, or true or false. So output would be true because any of one condition is true. So x plus plus. So x plus plus will be 11. Control goes to if block and else will not be executed. So sorry, x plus 12 will be x becomes 12. So final output would be 12 and 16 here. Final output is 12 and 16. So whenever first expression is false, it behaves like a normal bitwise operator. That you should know. So if you want to conclude, then what we can say is that in the case of logical OR, second expression would be evaluated only if the first expression is false. So first expression, if the first expression is true, then we can decide the final output is true. And in the case of bitwise operators, no matter it is true or false, both expressions will be evaluated. So whenever the first expression is false, these for both expressions will be evaluated. That is a thumb rule here. That's it, friends. Thank you for watching this video. I'm pretty sure that you would have enjoyed this video, so please like it, share it with your friends, and do subscribe to Geeks for Geeks YouTube channel. Thanks for being with us. Have a great day.